Hey everyone. Alright, so we're going to do linear, quadratic, and exponential modeling. So you have this lovely note here. We're going to use our note packet. So we're going to go down to the next page. So our objectives are listed here. So we're going to identify the patterns of each of them, identify your graphs, and identify your functions. So reviewing what that looks like, linear, x has no exponent, so you're going to have equations that will look like that. Those are all linear. Remember, it makes a straight line when you have your graph. Okay, quadratic, you have an x squared in there somewhere. Okay, so they'll all look like this. And then for your graph, you should have some sort of smiley face or frowny face. Okay, it should be up or down. And then for exponential, when we did our exponential unit, you have x as an exponent. So they will all look something like this. And then for the graph, it'll be sort of like a upward curve, which this applies more than ever right now because of our COVID-19 that we're dealing with at the moment. We're dealing with some exponential growth of that virus. So when you ask me when we're ever going to use it, right here, COVID-19. Have fun with that. All right, so some examples, just identifying the equations. So are they linear, quadratic, or exponential? So for the first one, x is in your exponent, which means you're going to have an exponential. Okay. For number 2, you have an x squared. Okay, and that characteristic is only of quadratics. For number 3, you have no exponents. You have, this is your slope-intercept form, it's just backwards. So this would be linear. And then for 4, if you move this 8 over, it's y equals 4 2x minus 8. The x is in the exponent. That's going to be exponential. They're going to try to throw you off by making it look a little different, but you just need to know these characteristics right here. No exponent, an x squared, or x is in the exponent. Right? So identifying the graph, we just talked about that above. So linear, it makes a straight line. There's no curve. Okay, there's no curve at all. Your domain, remember, will be all real numbers. So negative infinity to infinity. Range, same thing. It should be negative infinity to infinity. Quadratic, it makes a parabola. So you will either have it facing up or it'll be facing down. So your domain here, remember, is all real numbers, so negative infinity to infinity. And then your range is whatever your vertex y value is to either positive infinity or negative infinity. So for this one, for this example, it looks like your y value for this problem is negative 4. So it's going from negative 4 to positive infinity for this specific example. But remember, it's the vertex, whatever the vertex is, that y value either going up or going down. And then for exponential, you have this curve that rises or falls very quickly. So you have it either going down really quick, or like the one we drew above, it'll go up really quick. So remember, for your domain here, it's still going to be all real numbers because you can plug any x value in, but your range is going to depend on where this curve goes because there's this invisible boundary here. So for this example and this example only, you're coming from positive values. If you're going down to up, it's going down and it's getting close to your negative infinity or negative 5. I'm sorry, negative 5, and you can go to any positive y value. So if you're going down to up, we hit it. It can't be, apologies, it can't be negative 5, but it gets close to it. So you're going to have parentheses there. So that's what that looks like when you identify the graph. So we're going to go ahead and do that. So looking at these graphs, okay, looking at these graphs, you should be looking at this first one for A. It does have a curve shape like a parabola. So this would be your quadratic. for B, it has kind of the rising and falling kind of quickly. It's not a straight line. It's not a U shape. If anything, the U shape is like this, and we don't want that. So it doesn't have those things. So this one would be exponential. And then our last one, it's just a straight line. A straight line is always linear. Always, always, always. It's not curved up or down. It doesn't rise or fall like your exponential. So you should have linear. All right, and then identifying from the table. Okay, so identifying from the table for linear, you never see the same y value twice, and the first difference is always the same. So what that means is when we go through our chart, going from -1 to 1, we're adding 2. And then from 1 to 3, we're adding 2. And 3 to 5, we're adding 2. And you see it doesn't skip over here. This is all going up by 1. So if we're looking at the table, we can tell this is linear because it's going up by a constant rate. Okay, it's a constant rate that's being added or subtracted. So if we're writing the function for this, we know it's going to be in y equals mx plus b form. Okay, and one of the things we need to look at is where our y-intercept is, and that is at 0, 1. So for this, my y-intercept is 1, and my slope is the 2 that it's going up by. Okay, so your slope is that 2 that it's going up by over here, and then you have your y-intercept when x is 0, y is equal to 1. So now for quadratics, you see the same y value more than once, and then it says your second difference is the same. So what that looks like, if we're saying, okay, this is going up by 1, this is also going up by 1. So these two differences are the same, okay? And then we have this y value right here that's the same, okay? And this comes back to your axis of symmetry when you have your axis of symmetry for your parabola. Your parabola is symmetrical, so that means you're going to have y values on here, your y values that are going to be the same except for your vertex, because that's the center. It doesn't reflect on itself. So when we're looking at a quadratic, that's what it looks like. So now, all right, so we're going to talk about how to write the function for the table in another example. This is not a good example for it. So let's talk about exponential, and then we'll go on to an example where we can do all of these. So for exponential, you have a common multiple in your pattern, and you never see the same y value twice. So remember when we talk about exponential, we would look at what that pattern was over here. So from 2 to 1, you could add 1, but that's not really what we're looking at. We're looking at the rest of the pattern. If I multiply by 2, I get 2. If I take 2, I multiply and I get 4. 4 times 2 gives me 8, and 8 times 2 gives me 16. So remember, exponential, you are multiplying by some number, whether it's an integer or some sort of fraction. Because we didn't divide with this, we talked about that, we're not doing divide. So it's some number that's an integer or a fraction, basically any real number. But we do know it's exponential because we're multiplying, and that's a constant rate of multiplying. So you're going to see constant rate for both of these. But remember, constant rate of multiply is exponential, and constant rate of add subtract is your adding and subtracting, that's your linear. So from our table, to be able to write the function for the table, we need to put it in this form, y equals a times b to the x. Okay? Remember, b is your change that you're going up by, your constant rate, so that's your 2. And then your a is when x is 0. Okay, so your x is 0. If x is 0 here, 2 to the 0 is 1. whatever this y value is, that's what goes there. So this would be a 1. So you don't have to write the 1, so you could rewrite it as y equals 2 to the x. All right, and then we're going to come back and we're going to do this because this is not a good example of it. I want to make sure that we have a good example of how to find this. All right, so let's go to this part of the practice. All right, so scroll down, we're going to do this part of the practice. So I want to take a look at B. Okay, so B, we're going to do, so if we're looking at, is it adding and subtracting on the y side? It is not. So if you go, you have -1, then you have 0 again. So if you are subtracting 1 and adding 1, it's not going the way it needs to. It's not multiplying, it's not adding. This one's going to be your quadratic. Okay. So for your quadratic, for the table, for you guys at this point where you're at, you need to look at where y is 0. Okay, hopefully it's multiple times. It makes it a little easier. Because then where it's 0 is you can put it into its factored form. Okay, so if you remember when x equals 1, when x equals 1, it's a root, or when x equals 3, it's a root. So if we were to write this in its factored form, we would just go backwards, and this is a little bit more than you probably need to know. But if we were going back, we would say x minus 3 equals 0 and x minus 1 equals 0. These are your factors that you're going to put in for your quadratic. So I can say y equals x minus 1 and y equals x minus 3, and that's it. That's the equation for your quadratic right here. All right. So for your quadratic, from the table, ideally you would look for those two numbers. You can also use your vertex form, because if you can find your vertex, you can find your A, which is a little bit above what you guys need to know. But that is the example of how you would find that. Okay, so we took one of your homework problems and we took care of that. All right, I don't anticipate you having to do a lot with B, but you should see it. You should know it. All right, but that is the difference between linear, quadratic, and exponential. So those are the three that we've talked about so far this year. So make sure you understand the differences between those. And if you have any questions, come and see me during office hours. Have a good